Good day everyone, my name is Wilken Avila and today I'm going to present to you these three things. First is to discuss and identify the 5 major parts of a lathe machine. Second is on how to calculate the spindle speed that I'm going to use in this operation. And last is I'm going to perform the facing and turning operation on this given dimensions. So now let's start. So what are the 5 major parts of a lathe machine? So the 5 major parts of a lathe machine is first is the headstock, second is the tailstock, third is the carriage, fourth is the feed mechanism, and 5 is the bed. So headstock. So headstock is located at the left end of the lathe bed, contains the main spindle mechanism for obtaining various spindle speed. So the purpose of headstock is to provide different spindle speed and feed. So second is the tailstock. The tailstock, it is located at the right end of the lathe, and it can be adjusted along the bedway to suit the length of work. The tailstock primary functions are to support long work pieces, for setting center height or of tool bits. So third is the carriage. Carriage provides various movements to the cutting tool to perform various operations on the lathe. And fourth is the feed mechanism, just located below the headstock, so this enables automatic feeding for the tool longitudinally and transversely as needed. And the last is the bed. It's a strong bridge-like members made from high-grade cast iron and is heavily ribbed to give it rigidity. So that are the 5 major parts of a lathe machine. So let's go on the second, on how to calculate the spindle speed. So as we know, the formula of spindle speed equals to 1000 times cutting speed divided by pi times diameter. So as we know, the unit of the spindle speed is RPM. And the tool bit that we're gonna use today is the cemented carbide tool. So the cemented carbide tool has 90 to 150 m per minute. So that's the cutting speed that we're gonna use today. So spindle speed equals to 1000 times the cutting speed 90 divided by 3.14 times 30. So 1000 times 90 is 90,000, and then 3.14 times 30 is 94.2. So let's just divide it. 90,000 divided by 94.2, 90,000 divided by 94.2 is equals to 955.41 RPM. So this is the spindle speed that we are gonna use in today's operation. So let's continue. So now we're gonna do the facing and turning operation on a lathe machine simulation. So first we're gonna check the mild steel. So the given dimension of this mild steel is 100 by 30 millimeters. So first you're gonna click the mild steel and check it if it is 100 by 30. So the diameter is 40. Reduce 10, so that make it 30, and then offset is 85, and then double check it with the vernier caliper on the right side. Just click the vernier caliper and check if it is 30 by 100. So the diameter is 30, I think 30. And then the length must be 100. Okay, so length is 100 and the diameter is 30. Okay, so now Set up the tool bit, choose the number 5 and put it here. Okay, so number 5, put it right here, and then set up the lathe machine, and then move it right to the left, zoom into the headstock, check the spindle speed. So the spindle speed that we calculate earlier is 955. So you must find a number that is closer to our spindle speed earlier. So I think the 800 is the closest number, so I think we use 800 right now. And then this change, and then we're all set up. So I think move it to the right and turn on the lathe machine. Okay, turn on the lathe machine. Okay, so now we're ready. Change to camera angle 2. And then let's start. So the first is we're gonna measure 80 millimeters length and 28 diameter. So that diameter of this milestone is 30. So we must minus it by 2 millimeters. So set 2 here and then move to the left and stop at the 80 millimeter. Stop now. Let's check the calipers. Okay, turn off, click the vernier caliper and then check if it is 28 diameter. Okay, so the length must be 20, but earlier we checked it and it cannot reach to 80. It is only 78.9. So later we're gonna find a way to make it 20, to make Okay, so 21, 20.7. Okay, so now let's proceed. And then next is we're gonna reduce the diameter by 3 to make it 25 and stop at the length of 60. Okay, so we'll set it to 0. As you see, using bigger diameter or the interval to make our toolbit break. So first let's use small. So okay, let's check. Must be 25 diameter. Okay, so 25. And the length must be 40. Ooh, 40. Okay. So length 40 and then diameter is 25. Okay. So proceed and proceed to the next. So the next is the length. We must stop at 40 and then the diameter reduce the diameter by 5 so we can make it to 20 diameter. So reset it to 0 and then put number 2 mm. So first we're gonna use 2 and add 2 and then add 1 to make it 5. Let's continue. So we're gonna check the diameter. If it is 20, the diameter must be 20 and the length must be 60. Okay, so the length first must be 60. Okay, 60 and the diameter must be 20 diameter. 20. So I think it's right. So 60 by 20 diameter. So now we're gonna proceed to the next. So next is we're gonna reduce 5 diameter to make it 15, and then the length must stop at 20. Okay, so reset, put 2 here, last is add 1 millimeter to make it 5. So 1. Turn off. If it is 15 diameter and the length must be 60. Okay, so 15 diameter, the length must be 80, the length must be 80. Okay. Is 80 length and the diameter of 15 millimeter. So now we're gonna proceed to the facing operations. So facing operation is you must stop on the left top on the third row. First is you're gonna reverse. So just tap here. So as you see, the oil still has reverse. So earlier I measured it and it only stopped at 78.9. So now we're gonna reduce to diameter first here. So let's first gonna do the first step. So I'm gonna reduce it first here. So first just check if it is 28 diameter here. It's 28. Okay, it's 28. So now we're gonna reduce using facing operation. We're gonna reduce it by 20 millimeter length because the given dimension that we're gonna perform that is already only 80 millimeter length. So let's continue. So for the facing operation is we're gonna do okay, you're gonna move a little bit backwards, I think backwards down, and just put Do not force it to already big, no? As what I said earlier, 2 millimeters interval per work. So we're gonna reduce 2 millimeters and then add 2 after we reduce it, after it goes to 20 millimeter. So 2 first part. This is the facing operation. Let's turn off the machine and then let's check the vernier. Let's check it by vernier caliper if it is according to the dimension that we are given. So this is the final measurement. So the first must be 28 diameters. So first let's check the diameters. So 28. So the first diameter, largest diameter is 28. So 28, let's check. The first diameter is 28. Got it. the first diameter is 28 diameter. So I think it is correct. So the second is 25. So let's check if this is 25. Let's just check if it is 25. So let's just check. Okay, so the second is 25. So the third diameter is 20. So let's check if it is 20. Okay, so 20. So then the last diameter is 15. So let's check. So I think it is 15 diameter. And then next is the length. So the first length is 20. So all lengths are 20 and overall is 80. So let's check if the length is 80. Okay, so the length is 80. 80 length, 80. And first is gonna check if this is 20, 20, and 20. So first is 60. Okay, first is 60 length. So second is 40. So second is 40 length. 40 length. Okay, let's see. It must be 20. So 20. So I think we are finished. So this is the final product. So that's all for today, and thanks for watching.